Hey everyone, and welcome. Have you ever just stopped and wondered how your computer knows what a file is? You know, how it can tell that one thing is a photo, another is your favorite song, and a third is that big report for school? Well, it definitely feels like magic, but today we're going to pull back the curtain and decode the secret language that our computers are using all day, every day. It really all boils down to this one question, right? How does this box of wires and circuits know the difference between all these different kinds of information? The answer is actually way more simple than you'd guess, and it's the absolute key to how our entire digital world even works. Okay, so let's get right into it. The very first thing you have to understand is that deep down, a computer speaks a language that is incredibly simple. It doesn't get words or pictures or sounds like we do. Nope, it only understands this: digital data. Everything, and I mean absolutely everything, that you save or create on a device gets translated into a long series of just two numbers, 0 and 1. You've probably heard of it before. It's called binary code. So that photo you just took, the email you sent your friend, the video you watched last night. To your computer, it all just looks like this. It's kind of crazy, just millions and millions of zeros and ones, representing every single piece of information. When you really think about it, it's just wild. Our entire super complex, vibrant digital world is built from the ground up using just two little numbers. That is an absolutely incredible feat of engineering. Okay, but if everything is just a giant jumble of zeros and ones, how on earth does the computer make any sense out of it? Well, that's where what I like to call the computer's secret decoder ring comes into play: the file format. So, first off, the computer isn't just staring at one endless, chaotic stream of numbers. It's smart enough to group all that data into these neat little packages that we call files. You can just think of them as containers for all that information. And this right here is the really crucial part. The file format is like a label slapped on the outside of that container. It's the instruction manual. It tells the computer exactly what kind of zeros and ones are inside, and this is the most important part: which program it needs to use to actually read them. Just look at this. When a file is named myvacation.jpg, that little .jpg on the end is like a message to the computer that says, hey, this is a picture. Go get your photo viewer to open it. But without that little label, the computer sees the exact same zeros and ones, but it's totally lost. It has all the data, but zero instructions on what to do with it. All right, so now let's go on a quick little tour of the most common file formats that, honestly, you probably use every single day without even giving it a second thought. And we're going to start with the simplest one of all, the .txt, or just a plain text file. This is as basic as it gets, folks. The binary code inside a text file is just a direct translation of characters, letters, numbers, symbols. That's it. There are no pictures, no bold text, no fancy colors, just pure, simple text. Okay, now for something a lot more fun to look at. Let's talk about image files, like JPEGs and PNGs. For an image file, those zeros and ones are actually a set of instructions for your screen. The data basically creates a map, telling every single tiny pixel on your display exactly what color it needs to be. You put millions of those little colored dots together, and bam, you've got a photo. But what about stuff we hear? Well, for that, we've got audio formats like MP3 and WAV. In this case, the digital data is a description of sound waves. The computer reads all that data and sends these tiny electrical signals to your speakers or headphones, which makes them vibrate in just the right way to create the sound of a voice or a guitar or whatever you're listening to. So logically, the next step is to put moving pictures and sound together, right? And that is the job of video files, like MP4s and MOVs. Now, these files are seriously amazing feats of organization. They have to contain a stream of picture data, a separate stream of audio data, and then another set of instructions to make sure they both stay perfectly in sync. It's how we get to watch all our favorite movies and video clips. And finally, let's look at the documents we're all using for work and school, which are usually saved as either a PDF or a docx file. Now, these are way more powerful than a simple text file. Think of them as super versatile containers that can hold all sorts of things at once: formatted text, pictures, charts, different colors and sizes, all designed to look exactly the same whether you're looking at it on a screen or printing it on paper. So beyond the files that we make ourselves every day, there are a few other really important types that are working away behind the scenes just to make sure everything runs the way it should. I'm sure if you've ever had to email a bunch of files at once, you've probably made a zip file. This format is so cool. It takes your files and uses some really clever math to shrink them down and save a ton of space. It's basically like a digital vacuum seal bag for your data. And then you've got the real heavy hitters. An exe or an app file isn't just data anymore. It's an actual program. It has instructions telling your computer to do something, like run a game. And then files like SYS or DLL are critical parts of your computer's operating system. And I have to give you a quick but really important warning here. Leave these system files alone. Seriously, deleting them can actually cause your computer to stop working altogether. So at the end of the day, file formats are the essential language that translates those simple zeros and ones into the rich digital lives we all have. They're the bridge between the simple mind of the machine and the complex world that we want to create. And that leaves us with a pretty cool question to think about. As our digital creations get even more complex, things like virtual reality worlds or AI models, what entirely new languages and formats are computers going to have to invent and learn next?